There you go. Back up again. We're streaming.
Starting right now.
Welcome everyone.
Sound was the weapon, all right?
What could it have been?
I don't know.
I think it'll be a short stream today. We're gonna try and finish off the assignment. Assignment 3, I think it was. I think it was assignment 3. La la la. Yeah. These two last steps, those were the ones I still needed to do. Let me rerun some of this. A pickle file. Reformat. And then I think we're good. Okay, let me first go and refresh my memory on what Dropout actually was, because I don't remember.
There is another important technique for regularization that only emerged relatively recently and works amazingly well. It also looks insane the first time you see it, so bear with me. It's called Dropout. Dropout works like this. Imagine that you have one layer that connects to another layer. The values that go from one layer to the next are often called activations. Now take those activations and randomly, for every example you train your network on, set half of them to 0. Completely randomly, you basically take half of the data that's flowing through your network and just destroy it, and then randomly again. If that doesn't sound crazy to you, then you might qualify to become a student of Geoffrey Hinton, who pioneered the technique. So what happens with Dropout? Your network can never rely on any given activation to be present, because they might be squashed at any given moment. So it is forced to learn a redundant representation for everything to make sure that at least some of the information remains. It's like a game of whack-a-mole. One activation gets smashed, but there is always one or more that do the same job and that don't get killed. So everything remains fine at the end. Forcing your network to learn redundant representations might sound very inefficient, but in practice it makes things more robust and prevents overfitting. It also makes your network act as if taking the consensus over an ensemble of networks, which is always a good way to improve performance. Dropout is one of the most important techniques to emerge in the last few years. If Dropout doesn't work for you, you should probably be using a bigger network.
Okay.
When you evaluate a network that's been trained with Dropout, you obviously no longer want this randomness. You want something deterministic. Instead, you're going to want to take the consensus over these redundant models. You get the consensus opinion by averaging the activations. You want YE here to be the average of all the YTs that you got during training. Here's a trick to make sure this expectation holds. During training, not only do you zero out the activations that you drop out, but you also scale the remaining activations by a factor of 2. This way, when it comes time to average them during evaluation, you just remove these dropouts and scaling operations from your neural net. And the result is an average of these activations that is properly scaled.
Mm-hmm. I'll take this code. I should be able to run it. And then this code. Cool. Neural networks dropout. Okay. And they were saying you can use nn.dropout. nn.dropout question. It's not n. tfnn. Oh, no, I did that already. Do I need to add in that dropout somewhere during training?
Olives had a major run. Maraschino cherries, major run. No
Is
one
it
had a run
as
like
simple
mine.
as saying this dropout? Nah, that's not gonna work, is it? Keep prob. A scalar tensor. Yeah, scalar, same type as x. The probability that each element is kept. So I can't just add. Well, I would need to add a new. What do I do? Dropout. Mm-hmm. And I guess I need to initialize it as a certain value. Oh, what? Gallery. Let's try that, I think. Is it 17% each time? Maybe I need to do it here as well. So and this 0 needs to be something else, I guess. 1.5 or something. Try that. Doesn't make much difference. Let me try putting it on 1. Opacity, course, assign 3. Doesn't make any difference. Doing it. Let's see how this guy did it. Answer. So, deep learning solution. Someone had a repo where. No, that's not it. This guy's got something going. Problem design. Problem 3. Introduce dropout. hidden layer. Yeah. Yeah, that's kind of what I was doing, I think. Sure. Keep prob, and keep probs is... Right, and he says... Okay, let me try to understand what he's doing here. So he's adding the dropout here. Keep probability, yeah, that's just a float, that's what I also did. And the hidden layer drop is then the dropout, hidden layer, did that. Keep probability. Or did I do that? Ooh. Maybe I should not do it here, but rather for the hidden layer. Is that what they're also asking? Let's try that, see if that makes a difference. But these percentages are very low. Validation accuracy, is he's getting... These are all the... This is problem 4. Also. Okay. It's good. Nope. And the hidden layer, that's what I did. But what I'll do... I won't copy this one, I'll copy this one up here. Code. Oh. Copy this one over. Only I'll change that one. So the validation is pretty bad. 80%, whereas here I was getting 93. What do I get if I reduce dropout to 1.1? Still pretty bad. %, that's a little bit better, I think. Let's try out 0. 0 should mean that it does not drop out anything. I would expect this to be just as good as the having no dropout at all. Oh, no, no, this is, would be the opposite, even. Because this is the probability. No, I think I need to put this to 1. Try stripping it out entirely. This should be the 93. Yeah, 93.7. But it's not. Oh. Nope. 81.6. To be honest, I think this course is a little too advanced for me. Most of the time, I'm just doing stuff, hoping that it works. I don't fully understand what I'm doing, so just trial and error. Maybe I should start somewhere slightly less advanced. So don't know if Udacity has anything simpler. Deep Learning Foundation. This might be paid course. Probably. Explore. Beginner, yes, please.
At Udacity, we are here to prepare you for the jobs of tomorrow. Machine learning is one of the fastest growing and most exciting fields out there. And recent advancements in deep learning.
That's better. Hello world, it's Siraj, deep learning extraordinaire and YouTube star. Together with Udacity, I've created this program to teach you how to harness the incredible power of neural nets to do things like generate music, predict stock prices, and create chatbots.
Okay, hold on a sec. I'm Matt, and I'll be here to help you take all of this deep learning knowledge and apply it through problem sets and full projects using Python and TensorFlow. You'll also get your code reviewed by deep learning experts and get access to student forums.
With our powers combined, we're gonna make you a dope AF deep learning wizard, ready to revolutionize art, science, music, games, the entire world, if you can keep up.
Deep learning is at the cutting edge of self-driving cars, music generation, and the best automated translations ever achieved.
These applications are already changing our world, and we've teamed up to create a program where you can get in on the action too. The revolution has already begun, and deep learning is at the heart of it. We've teamed up to create a program to get you in on the hype train.
Whether you're looking for a job as a self-driving car engineer, AI engineer,
Or want to generate a symphony or detect faces,
then this is the program for you. You'll have access to all of Siraj's engaging videos on a huge range of topics related to deep learning, as well as weekly YouTube live sessions where he dives deeper and answers your questions directly.
they're all available online for everyone, but through this super exclusive partnership, you'll also get a full supporting curriculum taught by world-class instructors like Matt, plus all of Udacity's amazing services. That means hands-on projects complete with expert code review and weekly problem sets. Along the way, you'll have access to forums and an incredible community of peers. So get hype and sign up today.
Today.
Do it! Do it now!
Sure, bro. Wait, but is it? Intro to machine learning. Wait, but this, I guess this is not, yeah. I'm trying to learn the deep learning part, and these are not. I guess what I could do is finish off the course anyway. I don't know. I don't think it makes sense because I don't fully understand it yet anyways. Maybe no. First finish off a other course and then move forward with this one. Yes. That's fine. We'll just switch it up a bit. Yeah, let's have a look again what other courses they have. Technology. 3 courses. Android. Oh, excuse me. Oh. And this is all machine learning. Okay. Yeah, it's advanced. So beginner and zero and yeah, machine learning. Python. Data. Okay, I think I'll stop the stream here because I'm not gonna start anything else today. I think for next time I'll look up a new course that we can start. This one was a bit far-fetched, I think. It's a shame though, but I just can't properly follow along, so I think I'll just try something new, slightly easier next time. Or I might try a different project entirely, something not deep learning related or machine learning related. We'll see. We'll see. We'll just see next time. Regardless, thanks for watching, and see you guys next time.